Hello to all my friends here. Firstly, I want to thank ATCM 2019 for giving me this platform to share my new rule and my new game on topic solution of triangle to all my friends here. The objective of my rule is to let upcoming generation solve same problem on topic solution of triangle directly, more easily, and more accurately compare what's now solution. My rule is complement rule of topic solution of triangle. Pikachu rule is not only suitable for engineering math students, but also suitable for secondary school students because the topic solution of triangle is an important topic for engineering maths and secondary school maths. It is similar to topic calculus, which is also an important topic for engineering maths and secondary school maths. Gauss, sometimes referred as the prince of mathematicians, was not the first to interpret complex numbers graphically. Jean-Robert Argand produced his Argand diagram in 1806. Then Caspar Visser had described similar ideas even before the turn of the 19th century. But Gauss formally introduced the standard notation A plus bi for complex numbers and responsible for popularizing the practice. For my view, Gauss needs to introduce the standard notation A plus bi first to make clear picture of how imaginary number connect with real number first, before he gave a full image of his view on topic complex number. Same as me, I am not the first one discover a rule in topic solution of triangle. There is sine rule and cosine rule before me. Pikachu rule is the starting point for keep clear picture on this topic. It's like A plus bi, the starting point to topic complex number for Gauss. And I hope for future, I can also share with my friends here the full image of this topic on my view. As mentioned, there are two important rules in solution of triangle now, which are sine rule and cosine rule. We normally use sine rule to find the opposite side angle given. Okay, to find the side C for angle given, angle C, when we are given two angles and one side. When we are given angle B, angle C, and side B. We also can use sine rule to find the non-equal angle when we are given two sides and a non-equal angle. We can find a non-equal angle, angle C, if we are given B and C and non-equal angle, angle B. As we can see, we can find opposite side angle given when we are given two angles include one side. We can see we can find the side C if we are given two angles and one side. And also, we can find the non-equal angle when we are given two sides and a non-equal angle by using sine rule. We can get a non-equal angle, angle B, when we are given two sides, 3 and 5, and a non-equal angle, angle C. But sine rule is not suitable to find an equal angle when we are given three sides. When we are given three sides, if you want to find the equal angle, so you cannot use sine rule. Or to find the third side when we are given two sides and the equal angle. When we are given two sides and equal angle, if you want to find the third side, also cannot use sine rule. This is because if we use sine rule, we were having two unknowns. And as we know, one equation with two unknowns can't be solved. And you can see, if we use it, this one equation, we were facing two unknowns, 1, 2. If we're using this one, also we're facing two unknowns, 1, 2. If we're using this one, also we're facing two unknowns. So we can solve it by using sine rule. This is why we need to learn another important rule to solve the problem. Another important rule, as we know, is cosine rule. As we can see, we can use cosine rule to find the include angle when we are given three sides. When we are given three sides, 3, 5, and 6, we can find the include angle by using cosine rule. See, we can find the include angle A, 56.25 degrees. And also, we can use cosine rule to find the third side when we are given two sides and the include angle. We also can find the third side when we are given two sides and include angle by using cosine rule. You can see, we can find the side BC here. The side is equal to 5.385. Actually, for some questions solved by sine rule, also can use cosine rule to solve it. As we see from this question, we can use sine rule to solve it. We also can use cosine rule to solve it. If we're using sine rule, we just need to use sine rule once to get the final answer. We can see from here, if we use sine rule, you just need to use one and you can get the final answer. But if we're using cosine rule, we need to use twice to get the final answer. If you're using cosine rule, you see, you need to use twice, 1, 2, to get the final answer. So, using sine rule is more easy compared to using cosine rule. This is why we need to learn sine rule. Let us see for next example. If we're using sine rule, we just need to use sine rule once to get the final answer. You see, we just need to use once, we already can get the final answer. But if we're using cosine rule, we need to use twice, 3 times to get the final answer. You see, if we use cosine rule, we need to use 1, 2, 3. Then we can get the final answer. And this is why we still need to learn sine rule. But to find a non-include angle when we are given two sides and the include angle, what's now solution as we see from the book 8th edition for engineering maths written by John Bird. Okay, engineering maths written by John Bird. If we want to find the non-include angle Z, see, if we are given two sides and the include angle, actually we cannot find the non-include angle directly. Okay, one of the way now is using cosine rule to find the third side first. As we see from the engineering math book written by John Bird, page 248, is using cosine rule to find the third side first, and then use sine rule to find the non-include angle. And then as we see, use sine rule to find the non-include angle. For other sources, also same cosine rule plus sine rule. Okay, let us see also other sources. Okay, we can see using cosine rule plus sine rule. This one also same, using cosine rule plus sine rule. Today, I want to share my new rule to all my friends here. We can use it to find the non-include angle directly. I call it as Pikachu rule, and the rule is as shown. Tangent B equal to b sine c or divided a minus b cos c. As we see, use Pikachu rule is easier. Just 3 steps only. 1, 2, and 3. Compared to using cosine rule plus sine rule. See here, cosine rule plus sine rule, more than x steps. Okay? This is why we need to learn Pikachu rule. Besides being easy, accurate, and direct in finding the final answer, another advantage of Pikachu rule is we can visually determine the angle we want to find, like here, angle B is acute or obtuse angle. Cos Pikachu rule is using tangent, and as we know, tangent and acute angle will get a positive side, and tangent or obtuse angle we will get a negative side. Let us see the example provided. As we see, tangent B is negative side. So the angle B sure is obtuse angle. And let us also see the previous example. You see, tangent angle B is positive side. Then sure the angle B is acute angle. For what's now solution? As mentioned, is using cosine rule plus sine rule. And sine, either an acute or obtuse angle, also will give us positive side. So we cannot determine the angle we want to find easily. We need to use another calculation to determine the angle we want to find is acute or obtuse angle. Let us see the example provided. As we see, sine angle B is positive side. Here, sine angle B is positive side. And the angle B is acute angle. Sorry. We see sine angle B also positive side. But the angle B is obtuse angle. So, it is easy for students to make mistake of the final answer. Let us see the example provided. This one. When student gets sine B equal to 0.8739, they normally would assume angle B is equal to 60.92 degrees. The wrong answer. Actually, this relates with the main motivation for me to create my rule. The main motivation for me to discover my rule is the result of my mechanical class student. Previously, when I make this example provided, this one, as exam question for my student, 80% of my students make the same mistake on the final answer as I mentioned. So it made me think that I need to create a new method or a new rule or a new theorem to prevent my next student from facing the same problem again. After I discover my rule and introduce to my next class, this problem already solved. None of my students make mistake at final answer, cause it become easy already. By visual, we can determine the answer is acute or obtuse angle. And I believe this problem is still present at other places. This is why I want to introduce this rule to the world to help other students who take engineering maths or secondary students who take ed maths. Actually, for the beginning of my research, solve the problem that I mentioned is to find a new method, because a new method is more easy than to find a new rule or a new theorem. But after I tried about 1 week, I could not get a new and better method to solve it. And that I changed my plan to find a rule to solve it. Finally, I get Pikachu rule. Let me tell my friends here, how I discover my rule. For starting, I look onto the proof of sine rule and cosine rule. So let us see the proof of the sine rule first. As we see, sine angle B equal to h over c. See, sine angle B equal to h over c, opposite over hypotenuse. Okay, then we get h equal to c sine B. We let it as equation 1. And also we get sine angle C is equal to h over B. Sine angle C is h over B. Also opposite over hypotenuse. Then we will get h equal to B sine C. Then we let it as equation 2. And by substitute 1 into 2, from 1 we know h is equal to c sine B. Then we can substitute 2, h become c sine B. Then we will get c sine B is equal to b sine C. And after that, we will get c over sine C equal to b over sine B, and we get a sine rule. Let us see also proof of the cosine rule. We can see cos B is equal to A1 divided C. Cos B is A1 divided C. It's adjacent divided hypotenuse. Then we get A1 is equal to C cos B. We let it as equation 1. And by Pythagoras theorem, we get h power 2 equal to c power 2 minus A1 power 2. You see from here, h power 2 is c power 2 minus A1 power 2. And also, h power 2 is equal to b power 2 minus A2 power 2. It's by using Pythagoras theorem. And after that, we change A2 become A minus A1. See, A2 is A minus A1. And expand this power 2, we can get A power 2 minus 2AA1 plus A1 power 2. Arrange again, we can get this formula and we let it as equation 2. By substitute 1 into 2, by substitute A1 equal to C cos B to 2. So here will become A1 become C cos B. Then we will get B power 2 equal to A power 2 plus C power 2 minus 2AC cos B. Then we get a cosine rule. Now, let us see the proof of the Pikachu rule. As we see, cos B is equal to A1 over C. Cos B is A1 over C, like previously. A1 is equal to C cos B, like the as equation 1. And then we also get sine B is h over C, is opposite over hypotenuse, h over C. Then we get h equal to C sine B, like the as equation 2. And also tangent angle C is equal to h over A2. Tangent angle C is opposite over adjacent, so it's h over A2. And we also know that A2 is A minus A1. A2 is A minus A1. By substitute 1 and 2 into 3, by substitute A1 equal to C cos B, A1 becomes C cos B, and H becomes C sine B, H becomes C sine B, then we will get a Pikachu rule. When we look on cosine and Pikachu rule, it is same as beginning. We can see the beginning both rule are cos B equal to A1 divided C. See here, Pikachu rule, cos B, A1 divided C. And also, for cosine rule, also cos B equal A1 divided C. And also for sine rule and Pikachu rule, we can see also have sine B equal to h over C. This one is for Pikachu rule. Let us see also for sine rule. Sine B equal to h over C. So this is why I say, before I discover my rule, I see the proof of sine rule and cosine rule. For cosine rule, we can see the founder of the cosine rule used Pythagoras theorem as mentioned to build his cosine rule. As here, actually is Pythagoras theorem. This one also say h power 2 equal to p power 2 minus a to power 2 is the Pythagoras theorem. But for me, I want my final answer more accurate. So I will not use Pythagoras theorem. Because Pythagoras theorem involves square, then will involve square root. As we know, square root a number, normally we just can get approximate value only. The final answer will less accurate. As we see from Pikachu rule, I now use Pythagoras theorem to build Pikachu rule. See here, no Pythagoras theorem, no power 2, no square root. Okay, so using Pikachu rule to solve same problem will more accurate compared using cosine rule. I strongly agree with what mentioned by Agata Stefanovich from University of Birmingham. Mathematical proof is absolute, which means once a theorem is proved, it is proved forever. Until a proven though, the statement never accepted as a true one. For my view, no one can claim he created a rule unless he can prove it. As same as no one can conclude someone is guilty unless he can prove it. As we know, by symmetry, we can get similar formula for sine rule and cosine rule. You can see here, by symmetry, we can get a over sine A equal to b over sine B, or b over sine B equal to c over sine C. The same as cosine rule. A power 2 equal to b power 2 plus c power 2 minus 2bc cos A. B power 2 equal to a power 2 plus c power 2 minus 2ac cos B. The same as Pikachu rule. By symmetry, we can get 6 similar Pikachu rule. Let us see on detail. For sine rule, by symmetry, we can get a over sine A equal to b over sine B, or a over sine A equal to c over sine C. And the technique for V to remember is side versus angle. If the side is A, then the angle must be A. If side is B, then the angle must be B. Side versus angle. As same as here, if the side is C, then the angle must be C. Side versus angle. For cosine rule, by symmetry, we can get a power 2 equal to b power 2 plus c power 2 minus 2bc cos A, and also b power 2 equal to a power 2 plus c power 2 minus 2ac cos B. And the technique for V to remember is also side versus angle. If side is A, then the angle will be A. If side is B, then the angle also must be B. It's side versus angle. For Pikachu rule, by symmetry, we can get tangent A is equal to A sine B, or divided C minus A cos B, and tangent A is equal to A sine C divided B minus A cos C. And the technique for V to remember is also side versus angle. If the angle we want to find is angle A, then side here will be side A. See that if the angle we want to find is A, then the side is side A. And if the angle given is B, if the given angle given is B, so here will be sine B, and the denominator will be cos B. Okay, then if the angle given is B, then another side will be C, because it will follow A, B, C. You see from here, A, B, C. Okay, you also can see for other example, A, B, C, A, B, C, A, B, C, A, B, C. So, the technique for remember is very easy. The denominator will involve A, B, C. So remember Pikachu rule is as easy as remember A, B, C. So also need to remember is side versus angle. Okay, side versus angle. See here also same, side versus angle, side versus angle. Okay, this one also same. Let me show some example of application of Pikachu rule for mechanical engineering. As we see, what's now, if we want to find the resultant force direction, we need to use cosine rule to find the resultant force first. You can see here, we want to find the resultant force direction, we need to find the resultant force first. And then use sine rule to find the resultant force direction. And then use sine rule to find the resultant force direction. But by using Pikachu rule, we can directly get the resultant force direction. And also we can see Pikachu rule is more easy and accurate. You can see 1, 2, 3 steps. Here, how many steps? See? Cosine rule plus sine rule. Okay, this is why we need to learn Pikachu rule. As mentioned, we need to use cosine rule to find the resultant force first. Just how mentioned. And the value of the resultant force by using cosine rule normally just approximate value only. It is because cosine rule involves square roots as mentioned. You see here, the resultant force we get actually is approximate value only. Because you see here got power 2. If you want to get this resultant force, you need to square root 60.72. Then you get the approximate value of 7.792. After that, we still need to use the approximate value substitute to sine rule. After that, we still need to use the 7.792 approximate value substitute into the sine rule. You see here, substitute in sine rule. Ensure the resultant force direction value we get is less accurate. And we can see we get the resultant force direction by what's now solution is 29.45 degree. But by using Pikachu rule is 29.44 degree, 0.01 more accurate. As we see from engineering textbook by Jombert and other sources, all are using cosine rule plus sine rule. You can see here, Jombert page 249 for application. Then also using cosine rule plus sine. See, from engineering mechanical or mechanical engineering. Then you see, they are also using law of cosine and law of sine. Also Department of Mechanical Engineering, also using cosine plus sine. And I believe for future, all will use Pikachu rule to replace cosine rule plus sine rule method. Let me show also an example of application of Pikachu rule on civil engineering. What's now? If we want to find the degree of inclination for a landing tower, right here, we need to use cosine rule to find the original complete height of the landing tower first. We need to find AC first. So we get AC, but this one is approximate value. Okay, and then use sine rule to get the degree of inclination of the landing tower. But by using Pikachu rule as same, we can directly get the degree of inclination. Another example of application of Pikachu rule is we can directly find the angle of resultant velocity made with the bend. You can see here. Okay, we can also direct get the angle which is the resultant velocity make really bad. Let me introduce two methods how to get same accurate value with Pikachu rule by using what's now solution. Method 1 is we need to take value with 10 significant figure. As we see from the previous example, if we take value with 10 significant figure, let's say we see from here, okay, if we take 10 significant figure, 7.79238339, then when we substitute into the sine rule, then we will get the resultant force direction 29.44146394 degree. Actually, this one is as same as accurate with using Pikachu rule. Let us see example from Cambridge University Press. The value stage after using cosine rule is 4829931 continuously. And the purpose they use this is to get more accurate final answer. This one. Okay, as we know, as mentioned. And as we see, Cambridge University Press still use methods cosine rule plus sine rule to get the pairing of B from A. The pairing B from A. And by using Pikachu rule, just 2 steps only for this question. And you can see Pikachu is direct, simple, and more easy compared with method provided by Cambridge University Press. This one, 2 steps. This one, more than 8 steps. See? It's easier. If we look the previous engineering mode, normally we just use 4 or 5 significant figure only. See here? Here is just using 4 significant figure only. So the final answer will less accurate. Okay, the final answer will less accurate because normally we will ask students to get until 10 significant figure. Okay, so we also can see for mechanical engineering. See this one also for significant figure only, and the answer will be less accurate. This one also same figure is for significant only, so the final answer should be less accurate. Let us also see from online calculator Mac Portal. The value Mac Portal use is also 5 significant only. The value that they give after using cosine rule is 5 significant figure only. So if we use cosine rule plus sine rule method and use Mac Portal for helping calculation, the final answer also will less accurate because they are not using 10 significant figure. Another method 2, is we can use sine b equal to b sine c, or divided by square root a power 2 plus b power 2 minus 2ab cos c. It is from cosine rule plus sine rule, but the formula is too hard. I believe you correctly, this formula is too hard, and it also will face problem to determine final answer is acute or obtuse angle as mentioned. So using Pikachu rule is the better way to solve the problem mentioned. As conclusion, what's now for topic solution of triangle, just had sine rule and cosine rule. And I believe for the future, we will have sine rule, cosine rule, plus Pikachu rule. As a future research is a Pikachu triangle diagram. Actually, this one almost done by me. And application Pikachu rule on mechanical and civil engineering. Just now I also one example for each, but I still want to study further. Okay, how to apply Pikachu rule to geometry software, and how to apply Pikachu rule from calculator design and online calculator. Reference is as shown. For information of Pikachu rule, you all can search Pikachu rule at Google. Search at Google, type Pikachu rule. You see here, if you type Pikachu rule, you will get a new important rule, Pikachu rule. Then you click in, then you will get some information of Pikachu rule. Or if you know how to type Chinese, just search my Chinese name Zhou Yi De at Google. You also can get this one. Actually, you click in, you will get information of Pikachu rule. Okay, if you get this page, it's a click this one. Okay, you get this page, you just click this one. Mathematics is known to be a challenging subject for students in secondary school across the world recently. Some mathematics researchers and educators have adopted different methods, ideas, and approach of trying to address the challenge. As a result, there is need for new learning solutions to help students sustain interest and promote effective learning towards mathematics. One of the ideas is from Conrail Workframe, teaching kids clear maths with computer. My idea to help students sustain interest and promote effective learning in mathematics is by designing a mathematical game for students. Let me show an example for my mathematical game. The objective of this game is to help students enjoy and remember rule of topic solution of triangle. Instead of sine rule and cosine rule, students also need to remember Pikachu rule on this game. This is the first page of the game. If player want to have a look for the rule before play, he can press the leading photo here. The leading photo here, press, then you will get the rule. Okay, and then you press escape, will return to the first page again. And if you want to start game, just press the PECET mathematical logo here. When you press this one, then the game will be started. The time given of each player is 30 seconds. This one, when you start, is 30 seconds. Player needs to press the PCET logo here. Player needs to press PCET logo here, which move randomly. This one will move randomly. If player succeeds in pressing a PCET logo, success pressing, a statement will come up. Then a statement will come up. Okay, and will show correct and wrong logo. Okay, when the correct logo pressing, when started, you get this statement, the logo not yet pressing. It gives you time to think, is this correct or wrong? After 3 seconds, these two buttons will flashing. Okay, and when the correct and the wrong button or logo is flashing, then the player can start pressing the logo. If the statement is true, player need to press correct logo. If you think that it is true, then you press the correct button or correct logo. Then player will given 5 marks for score. Here will be adding 5 marks, and so plus 5 seconds for timer. And this question will disappear. But let's say if player answer wrongly, this one is correct, then if player press wrong, then the game will start. Okay, or if the timer is equal to 0, it will show out a high score, and then the game also will start. When player reach score 100, then a page saying you win the game will come up. When the score is 100, then a page saying you win the game will start. You already get a high result. Congratulations. At first, I just let players play before teaching them any rule to ensure no one can win the game if do not know the rule. Until today, no one can win the game before they know the rule. Let us see the video. As we see, they cannot pass the game before they know the rule. After that, they ask me to teach them the technique to remember the rule so that they can win the game. And I teach him and I teach them the technique to remember the rule as mentioned. After that, they win the game. Let us also see the video. As a reward for passing or winning the mathematical game, I give them a box Rolo Bubbly chocolate. You can see it's Belgium handmade chocolate. As we see, not only they enjoy for learning, you see the smile face here, they enjoy for learning, okay, and I also enjoy for teaching as a smile face. Yeah. Actually, I already have 100 similar games for different topics and 4 different types of mathematical games. For those who want to try playing my game, meet me at ATCM 2019. Okay? I would have a demonstration at a workshop for mathematical games on Cosmate 2019, which is organized by Simo Laksam at Penang, Malaysia at 11 till 15 November. Simo is Southeast Asian Minister of Education Organization, and Laksam is the Region Center for Education in Science and Mathematics. I will show the result on ATCM 2019. I still have 3 unpublished papers, and the objective of that 3 unpublished papers are to improve the calculator design and to improve function for online calculator and apps for Macs. After I look detail on the present function of cashier calculator, online calculator, Mac Portal, and apps Photomax, I believe the objective of my 3 unpublished paper result can be subset. I do not plan to present my 3 unpublished paper above at any international conference or published at any book or journal. The main reason is I want to work together with a developer mentioned and make some special function at their product. As we know, calculator, online calculator, and Max app presently just contain knowledge that already states a book. As example, sine rule and cosine rule. Like symbolic, you can see, just have sine rule and cosine rule. And also, calculator should online, calculator also cosine and sine only. Okay, you can see just cosine and sine only. Okay, so I believe your product contains some knowledge which are not inside the book, or I call it as future knowledge, can attract more users to use it. Let me use online calculator Mac Portal as example. If we use Mac Portal, we can see Mac Portal just can solve the problem which can solve directly by sine rule and cosine rule only. You can see here, sine rule and cosine rule. If you give them the problem solved by sine rule, it will show you the solution. You put the question which solved by cosine rule, they also will give you the solution. But if you give them the problem that need to solve by cosine rule plus sine rule as mentioned, he will give you error. So Mac Portal cannot solve problem need to use cosine rule plus sine rule as mentioned. So I believe if they use Pikachu at their design, they sure can solve the problem mentioned. So here won't say error here. But it's still not enough. They still got problem which cannot solve by Mac Portal and also Pikachu directly. Anyway, I already have full image of topic solution of triangle, and instead on my paper called Pikachu triangle diagram. With knowledge of Pikachu diagram, all problem at topic solution of triangle can be solved. Then all won't have error here. Okay, all will have solving. For those calculator developer, online calculator developer, game developer, and app developer are interested to work together with me, please contact me +6019 558 3192 Pikachu, or either it's HP, calculator suit, or symbolic or photo. hand calculator also are welcome. Finally, I hope FieldMac researcher, calculator developer, online calculator developer, game developer, and Max app can work together to create something new to help our upcoming generation learn Max easily and happily. Thanks for listening. Bye.